Hello guys, welcome to the channel MS Mechanical. Today we are going to see what does the strength of material what is a strength of material, what does the strength of material mean. Some of us may be learning, we don't know what the subject strength of material may mean, but we just start learning it without any basics. We are going to see what the strength of material is, what is this basic behind stress, what is the basic behind strain, and which comes first, stress or the strain, which comes first. Let's see which comes first, stress or strain, in this video. Watch to the end to know about this. Let's first see what is a strength of material mean. What is a strength of material? What does a strength of material mean? The strength of a material is nothing but whenever a force, let us consider this as a material. Consider this as any material. A force is acting normally, or maybe transverse or shear, whatever it may be. A force is acting on this material. We know that this material is made up of number of particles, atoms and molecules. There will be number of more atoms in the first very layer. There is atoms in the second layer too, and there is atoms in the third layer. We all know that. And these atoms are bounded to each other with a force called cohesive force. When a load is acting, let it be P, kilonewton, is acting on this particle, then what happens? When the load first acts on the particle, there is some deformations. When this molecules gets knows that there is some deformation, they thinks that somebody is trying to separate them from each other. These two atoms or molecules, whatever may be, they are very fond of each other. They are have love with each other. So whenever anyone tries to separate them, they keep more force and they will be together. They try to be together. This is called, the trying to be together is called stress. Okay, there is a resistive force. The trying to be together there is a resistive force. This resistive force if you take this unit area of length or breadth something, in this unit area, when you come to this unit area, particular area, the resistive force which is stopping the deformation to happen, that resistive force and on the unit area is called the stress. That resistive force is the force per unit area. This section on this cross section is called the stress. Okay, let's see what is strain. We just saw what is stress. Now we'll see what is strain, and in the end we'll see which comes first. When there is some cohesive force, I told you the cohesive force is nothing but the loving force which makes them bring together is called the cohesive force. When this force is bigger than this force, resistive force, when this force P is much greater than the resistive force R, at that time what happens is there is some separation between them and there is some deformation. If this happens in this, if you consider now, if I am rubbing this and let the force be acting this on this side direction, let it be tensile force, then what happens? This part, there is atoms in this part, and this and there is also atoms in this part. Let us consider this cross section, let it be xx. What happens at this x's? X and x dash. Let us consider this cross section be x and x dash. What happens in this x and x dash? There is a force P, there is also a force, pulling force P. what happens here is, at this direction there will be this molecule will be producing a resistance force of R1. This molecule will be for resisting force, let it be capital R1. This molecular force will be R2. This molecular force will be producing resisting force R3, and this molecular force producing R4. If this P is much more greater than R1 plus R2 plus R3 and etc., the resistance force B, there is no place there as the stand is disturbing my way. P is much more greater than R1 plus R2 plus R3 plus R4. In that case, what happens? There is the molecules here. I'll be drawing here the cross section here. These molecules and these molecules, there is a separation between them, and the length increases due to tensile force. If this is happening a compressive force in this way, there will be a reduction in the length. The body tends to deform in its length. Hence, this is called as strain. Strain is nothing but the deformation happening. But in the unit, the deformation to the total original length is the strain. The strain is denoted by the letter E. Let's say any deformation, any dimension, change in dimension to original dimension. Original dimension. This is called strain. If the strain takes place along the length, then it's called del L by L. Along the diameter, then D by D. Okay, let's see what comes first, stress or strain. Which comes first? Okay, take a material, consider this as a material. I'll wrap this, we'll get a much better view. Consider this as a material and a force is acting on this. Consider it is a normal force acting. Then what happens? There is some deformation. First, a deformation occurs. Then what happens? The molecules get alert. Then there is a coercive force. They put more force between these two and held tight with each other like two friends. Example, there is a whole class and two friends, they are best friends. When teachers tries to separate them, they are more talkative friends, they are good best friends, and they are disturbing the class. What happens is, when the teacher comes and asks them to separate them, a boy sitting in this bench, and they are asked to separate and go and sit in the other first bench or not. So what happens? Then these both friends catches hand and they will say, I am not going with anyone. In the similar way, these two atoms, they say that I am not going to go. If the force is more, the teacher is more powerful than these two guys, they will separate them off. If the teacher is less submissive little, then the resistive force produced by these two guys, then what happens? They normally sit on the same path. They will not get any deform. The similar way, when the teacher is coming to scold them, that is a force P, let it be P, and the boys gets alert. And then what happens? First the teacher comes and first they try to push each other. Then the boy gets alert. Then what they will do? They'll bond their hands very tight and fit and firm. Then there is a cohesive force between these two guys, and these two guys, let A and B, there is a cohesive force between these two A and B, that is the particle A and B. The boys, the particles does not move in their place. If the force is applied, external force is weaker, then there is no deformation. If there is the external force, teacher is much more stronger than these two boys, then what happens? They have to literally go and sit on separate benches. This is the strain and the stress. So first, the strain occurs when an external force is acting. Then what happens? The stress occurs. Strain is the result. The external force, the teacher, the external force, that the teacher is what? The action. The strain is the result. The stress is the reaction. First this one, second the result occurs, a little bit results occurs, then the reaction occurs. If the reaction fails, then the result will be shown.